Hi everyone, and welcome to our video on finding the average rate of change when we have a function. So here we have a function, but first let's go and get our formula down for the average rate of change. So let's write it. So the average rate of change, which we usually call AROC, I'm going to put it just right up here for now. There's two different formulas that are the same, they just look different. We have y2 minus y1 over x2 minus x1. And then notice this is the same as a slope, m. All right, so you could use m if you prefer. But the other notation is to state, well, y2 and y1 are from plugging in x2 and x1 into a function. So this would be the same as f of x2 minus f of x1 over x2 minus x1. All right, so let's break this down. So we want to find the average rate of change. We do have a function here, so f of x, and then we do have our x1 and x2. Okay, so we've got all of our information. And so let's set up our average rate of change. Now I'm going to set this up in a horizontal line right here. I'm going to do the y2 minus y1 over x2 minus x1 notation. Okay, and we could set up the bottom. So x2 and x1 are ready to go. So x2 is 5. And then minus, careful, it's negative 2, so 5 minus negative 2. So I'm using parentheses to make sure that that's going to be okay. All right, the y2 minus y1, though, are not instantly seen. What we need to do to get them, so I'm going to do y2 first, is to evaluate f of x2. So I'm just doing this below. So this is kind of my scratch work. I'm just going to do a squiggle. The rest of my main work should fit up there. And so x2, they're saying is 5, so you should change that to 5. There we go. And then now, just like any function, I'm just going to kind of underline it. It's saying change those x's to 5s. So we'd have 5 cubed minus 2 times 5. And then we keep going with it. Okay, so 5 cubed is 125. 2 times 5 is 10. And so we get 115. Okay, so what we've got, so all this one long line, but let's put a little arrow. It's saying y2 is 115. All right, so we've got y2. I'm going to cloud it for now. Let's get y1. So y1 is to do f of x1. Well, x1 we see is negative 2. So back to the information from the start. So we would have f of negative 2. And then now it's again right back to our function, still just underlining, changing those x's into negative 2's. So use parentheses, so negative 2 cubed minus 2 times negative 2. And then order of operations, or again, calculators can help. Negative 2 cubed is negative 8. And then negative 2 times negative 2 is positive 4. And then this simplifies to be negative 4. Okay, and I clouded it a little early. Let me erase that. Let me match my notation from above. Okay, so that's one long line, but it is still connected to y1, so we're saying y1 is negative 4. There we go. And then now we can plug those in. Okay, so back to our top here. So we've got y2. Here's our y2. They're saying that is 115. And then minus y1. Here's our y1. So minus, notice y1's negative again, so careful, make sure to use parentheses like that. Okay, so there's our big setup. And then now we've got all of it. We have our final setup, and now it's order of operations. Remember, those parentheses are there. So if you are doing it in a calculator and you're doing it in one big step, those parentheses are often needed if you're using like an 83 or 84 or an older calculator. Okay, because it doesn't match the notation. Desmos, it should match the notation. All right, but when we do add this, it looks like it's 119. And then 5 minus negative 2 is 7. And then this might be fine. Let's see if it reduces. Okay, so I'm just doing a little scratch work to the side here. 7 doesn't go into 1. It goes into 11. once, oh, it does reduce, 17. There we go. Okay, so that's the average rate of change of that function. Okay, and as a visual, so I don't know exactly what it looks like, and I kind of have a lot of room squeezed out of it. Okay, so, but it probably looks something like this, the actual function that's graphed there. So this is the y equals f of x graphed, and they're saying from -2 to x equals 5, you would have that slope is 17. Okay, so it's going up 17 and then to the right 1. So it's steep. Okay, so my picture doesn't look like it. Okay, so what this number is telling us is that this graph is going up pretty fast. Okay, so just a quick number to help us with that. Okay, anyway, that's it though. If you have any questions, please let me know. And thank you for watching.